All right, so we're taking a look at this question, talking about the current in a wire and the time it takes for a certain amount of electrons to pass a certain point in the wire. So I want to just start off reminding ourselves that the current is equal to the amount of charge that flows in a certain amount of time that it takes. Okay, and so if our current is 3.5 amp, short for amperes, that means there is 3.5 coulombs going by every second. Okay. Now, what is the charge that's actually moving in a wire? What we know is that in most situations, the electricity that is flowing is made up of electrons. And so a way to think of this charge is to think of it as a number of electrons multiplied by the amount of charge on one electron. And that would tell you the total amount of charge. If you take the total number of electrons times how much charge one electron has. And so we're being asked to figure out this number of electrons. And the hint to this question says we need to use the elementary charge. Remember, the elementary charge is the amount of charge there is on one electron. That is 1.6 times 10 to the negative 19 coulombs. Okay, and so we have a couple different approaches. We could do this a little like algebraically, or we could work through this step by step. But at the very least, I definitely would like to solve this for the amount of time is equal to the amount of charge divided by the current. Okay, remember the current, the symbol for that is I, so you might see that in one of your formulas. And I'm going to rewrite this as number of electrons times the elementary charge. Remember, the symbol for the elementary charge is just the letter E, divided by our current. And I'm going to do a little bit more algebra to move. I want to move current and E to the other side. So I'm going to get it is the current multiplied by the amount of time. Remember, that would give us the total charge divided by the elementary charge, which if we think back to our sort of our definition here, we're saying that the total charge is equal to the number of electrons multiplied by the charge on one electron. So again, this is going to give us number of electrons. And for this question, I'll plug in my numbers. The current is 3.5 amps multiplied by, oh, I solved this for the wrong thing. So let's see, I need to solve this for the amount of time, which is already written out. So I'm going to plug in my number of electrons, 2.5 times 10 to the 19. Number of electrons, no units on that because it's just like a number, like we're counting, multiplied by 1.6 times 10 to the negative 19 coulombs. That is the elementary charge, the charge on one electron, divided by 3.5 amps. Okay. And I'll go over to my calculator and I will do 2.5 times 10 to the, just check that number, 19 times 1.6 times 10 to the negative 19, all divided by 3.5. And I'm going to get 1.143 seconds. Now, that doesn't seem like that much time, right? But remember that each individual electron has a very, very small amount of charge on it. So even though it's 10 to the 19 electrons, this number makes sense. All right.